Okay, so it's really fun to see our simulation move around under the pressure of the forces we've applied. But how can we capture that kind of graphically? Well, let's look at a way to output our simulation to a video, right? And this is a kind of multi-step process. It's not just kind of export, but it's not that difficult. So instead of looking at just only seeing the current state of our simulation and having to reset and start it again, we're going to look at a way to capture all of the states of our simulation between two moments in time. The way we're going to do that is we're going to use the frame sequence object. This allows us to specify a time sequence as opposed to start and or reset, or start or stop, which are our only controls now. We're going to look at a way to control how many frames should the simulation run for, and then how can we capture them, right? So if this is generally the graph of what we've been doing thus far, right? If we have an indication of time and an indication of equilibrium, as we move through time, whenever we hit we turn our Boolean toggle from true to false to allow it to simulate, and we let the timer block be released. As we're watching in time, we're seeing our shape move from zero equilibrium up to a state of almost pure equilibrium. And the longer we let it play out, the closer to 100% equilibrium we'll get, right? This part of the curve is kind of what we saw when we were comparing the spring lengths before and after. It would kind of bounce around a little bit, but generally it was not moving, right? So it was kind of plateauing out into as much equilibrium as it could have within that shape, right? So what we're going to do is we're going to, instead of just seeing the current moment in time, we're going to capture all of the moments in time between two extremes, like 0 frames and let's say 120 frames. Okay, and then what we're going to do is bounce over to, we're going to animate our simulation and capture each frame so that in Photoshop we can compile it into a GIF, right? And that will be something, it's just a lightweight file type that we can use to show motion, right? You can do more interesting things with video and like using Adobe products, etc. to composite or kind of compose your video, but we're just going to stick with a simple GIF for the purposes of this course. Okay, so let's choose one of the files that we developed thus far to simulate, right? I think this one's pretty good, but maybe let's bounce over to the grid shell, right? Because that one was pretty straightforward. So I'll get rid of all this stuff out of my file except for my original mesh. I'll make it flat again. So it's all residing on the C-plane. And while I'm here, I'm also going to move it a little bit away from the origin. And I'll see why I'm doing that here in a second. All right, so let's open up the grid shells file that we were working with together. To give you a hint of where we're going, 1-4 simulation capture. This is the key change, right? Everything else is pretty much the same, but we have to, instead of supplying just our toggle and timer, we have to supply a few more properties so that our simulation acts in the way that we want it to, in a way that is conducive to capturing each frame for video. All right, so here's my grid shells file. I'm going to go ahead and save this as simulation capture working. All right, and what we're going to do is we're going to zoom in to right here, simulation controls, and delete. Right? So what was just a Boolean toggle and a timer is going to become a few more objects that are going to be mostly found under the kangaroo, then kangaroo subtab. We want a sequence as well as the kangaroo settings object. All right. So let's start with the sequence because that's pretty straightforward. when we're using the Boolean toggle and the timer, right, what is essentially happening is that we're saying when we start true, so reset, then whenever we say false, right, that's the first frame. What the timer is doing is telling this object to solve again, so it finds false one more time. So every time we want to frame, it's finding that this says false, and it keeps going, right? So the timer is just telling this object, or whatever object it's connecting to refresh. So instead of just supplying one value and having the timer determine the refreshing, let's go ahead and use the frames object, because this allows us to just say how many frames do we want, and it will create the list of trues and falses that will result in that many frames. All right? So frames is just a number for how many we want. Let's go ahead and grab a panel. Double click. Generally, we'll be working at 30 frames per second. So if we want a 3-second animation, it's going to be 90 frames. So go ahead and specify that in my panel. So this is my number of frames. Hook that up. All right, so now it's going to say true and then false a bunch of times until we reach 90. All right. So that's going to allow us to, if we specify this for simulation reset, this might actually take a second to calculate, because instead of calculating just the current solution, it's got to calculate all 90 of them. All right. So here we have now our physics engine set up, and we can optionally use the settings to determine how fast it should find equilibrium. Right? By default, whenever we're using Kangaroo, in the settings, it's actually using what's called a sub-iteration. Right? So it actually calculates 10 times before it updates what you see, so that it can show what's happening faster. Right? So if we only want 90 frames, like we want a 3-second animation, but we want it to reach equilibrium faster, we could increase the sub-iterations by specifying a higher number than 10 into this input, and then use the settings here to replace the default settings. All right, or if we want it to go slower, of course, we could reduce that down to 5. All right, so I'll call this the sub-iterations. So label for my panel. And you can also start to look at some other ways to change the global settings for the physics engine in any of these inputs here, settle, tumble, etc. All right, so we'll just work with the sub-iterations for now. All right, so this looks like everything's happy. Let's take a look at the geometry coming in is 2,121 points. Right? Those are all of our vertices. Right? What was coming out before was another 2,221 points. Right? The same points, just the current frame of the simulation, that they've been moved in their position based on the pressures that are at play here. But what we have now is 190,890. So what's happening is every frame that we ask for this to calculate, it's creating that set of new points for our geometry output, and then it's doing the next, and then the next, and then the next. So what we need to do is we need to break up the list of points that are coming out of geometry out, so that we can move through each frame and see what the current value is. All right, so what I'm going to do is I'm going to slide this part of my file over, and here, instead of just one big list, I'm going to use under sets list the partition list. It takes one list and puts it into sublists. Right? So this asks for the list of partition. That's my points here. The size of partitions. That's how many values do I want in each partition. Well, I want as many values as I had points originally. So 21, 21. So I'm going to grab the list length from my vertices, and that's what's going into geometry here. Give this a faint wire display also so that it's a little bit easier to see what's going on. And now I need to have 2121 repeated for as many frames as I have. So I'm going to do a repeat data from set sequence. This is my data. This is how many times to repeat. And then this is going to go into S so that now I have a data tree where each branch is one of my values, right? Okay, so for now, let's go ahead and say that we want to retrieve a specific branch of that data tree, and that's what we're going to actually see. So if I go to tree statistics, this allows me to pull out the specific paths that I have. Right, those are the data paths as strings. And then I can create a slider that goes between 0 and 89. So that's how many frames I have. Put in a slider. Let's go ahead and edit this slider. It's going to be integers. This is my number of frames. So 0 to 89 gives me 90 values. All right. We'll call this current frame. Hit OK. And then I'm going to choose this as a specific list item from the paths. So I'm going to move through each of the current frame index values to grab the specific path so that I can grab the specific tree branch. So this is my path and this is my tree. Right? Now this is going to replace anything that was previously coming from geometry out. So this is my points and what's going to compose my mesh. Right? So now if I scrub through this, each one of these moments in my simulation is showing me a different frame from what's going to become my animation. Right? So I can turn the preview off of this stuff. I'm going to change my preset back to something that's a little bit more nice to look at.